What a great initiative you guys have. Very excited that this is the highest points reward of today. So it's fully packed. It's going to be really meaningful, I hope. So I'm very excited to get into it. So I'll start by sharing my screen and letting everyone know what's going to be happening today. So let me just present. I'll make that full screen. Okay, great. You should be able to see my PowerPoint. Let's get into it. So Algorand is an institutional grade, developer friendly, utility driven blockchain. My name is Sarah Jane Kenny. I'll be taking this session today. I'm really excited to show you what's in store, but a tiny bit about me. I'm an Algorand Foundation developer champion. I've been working in the Web3 industry for 3 to 4 years now, and I'm also currently a software development student in university. So what's in store? In this workshop, we'll be giving an intro to blockchain and Algorand technology, which will just take around 10 minutes or so. Then we'll get into the live coding and building with Python. And then afterwards, I'll showcase Python and Algorand using with smart contracts and deploying it. Then I'll show you how to set up your local environment so you can start to do this outside of Codespaces. And finally, we'll talk about hackathons and bootcamps galore. Firstly, why is blockchain needed? So you can see a little word cloud there, but if I was to pull out some words, there's authenticity. So using the blockchain ensures trust by verifying the authenticity of data and assets, enhancing reliability in transactions. We also have supply chain transparency, which is really growing. That basically tracks products from origin to destination, ensuring transparency and even preventing counterfeit goods. Another one I can see there is mutability, which is used a lot with blockchains. So basically with immutability on the blockchain, it creates an unchangeable record, which basically provides a secure and reliable system for securing information. And then another big one that's coming up these days is all about security. So with blockchain, you can utilize encryption and decentralization to safeguard data, reducing the risk of fraud or unauthorized access, and so much more. But let's get into Algorand. What is Algorand? So Algorand is a layer 1 blockchain. It all started back with Silvio Macaulay. He's an Italian computer scientist and MIT professor. He's known for co-inventing probabilistic encryption, zero-knowledge proofs, verifiably random functions, and of course, Algorand, which was founded in 2017, but the first Genesis block, as you can see on the PowerPoint, was in 2019. Specifically June 19th, if anyone shares the birthday with the first Genesis block of Algorand, which would be pretty cool. In one sentence, Algorand is an enterprise-grade programmable layer 1 blockchain with instant finality and low fees, enabling consistently high TPS and requiring minimal energy use. And that enables solutions that scale. Our technology, our tooling, and the investments Algorand Foundation does, everything they do is all about enabling innovative real-world solutions at scale. And only at Algorand can we talk about true scalability without any sacrifice to performance. So let's talk about the performance. So here are some stats. We currently have a theoretical TPS of just under 10,000. TPS also stands for transactions per second. Our second block times are less than 3 seconds. So it takes less than 3 seconds to get your transaction across. We have a 0.001 algo fee, which is basically like a tenth of a US penny. We have instant finality. which is rare in blockchains, but a need for consumer adoption. And I'll talk a little bit more about instant finality in a later slide, but that's a key point. Algorand mathematically cannot fork. So that means a fork is when a blockchain splits into two competing paths. It's very important to not fork because it can keep authenticity and rarity where it needs to be. For example, there can't be two Mona Lisas. We also have no rollbacks. A rollback is a reverse of a series of confirmed transactions, which doesn't really sound very decentralized. We also have had zero downtime since inception. As of January 2024, it has been recorded Algorand has produced around 35 million plus blocks, a huge 1.4 billion transactions, and 600,000 active users on chain. Let's take a look into the core technology of Algorand. So the most important and fundamental task in a blockchain, any blockchain, is the secure, reliable, and fast creation of the next block in the chain. The tool to create and validate the next block in a blockchain is called the consensus mechanism. Early blockchains use a consensus mechanism called proof of work, like Bitcoin. While this was useful at the time to prove out the concept of a blockchain, it has been shown to be very slow, expensive, and energy inefficient way to write the next block in a chain. Algorand uses an innovative consensus mechanism called pure proof of stake, the first ever one. And that's how they write the next block in the chain. Consensus requires 3 steps: to propose, confirm, and write to the blockchain. These steps include 1, propose phase. One account is chosen to propose the block. 2, the soft vote phase. Committee is chosen to soft vote on the proposal. And 3, the certify phase. The new committee chosen to vote on certifying the block. Each block has a new proposer and new committees chosen at random using the power of VRF, which Sylvia Macaulay co-invented. This leads to player replaceability, a powerful tool that enhances the security. So anyone who has a token can participate, and there's no static target to attack. There's no heavy computation and debilitating energy consumption, as VRF is a simple task. The entire process takes less than 4 seconds. This is how Algorand has solved the blockchain trilemma and is creating a blockchain that has a global scale, robust security, and true decentralization at just the consensus mechanism level. Technology you can trust and everything you need in a layer 1. So I'm really excited to go through these parts. So the first one is Algorand smart contracts and development as a whole. So Algorand makes it easy to tokenize, transfer, and program conditions on any instrument of value. You can create fungible and non-fungible tokens with a single transaction where no smart contract code is required, which we'll be looking into later. Or you can program more sophisticated decentralized applications with Algorand smart contracts. Developers can write smart contracts in Python and can use one of 4 SDKs, Python, JavaScript, Golang, Java, to connect to on-chain assets or applications. Then we have Algorand standard assets, and they're appealing for many reasons. An ASA is basically a token on the Algorand blockchain. So it inherits basically everything great about Algorand: the efficiency, the scalability, and security, and many more. Then we also have atomic transfers. An atomic transfer basically allows multiple transactions to be grouped together and executed atomically, ensuring that either all transactions succeed or none of them do. And this is really key to truly trustless transactions. And that's also a feature of Algorand. So it's a lot easier to program. We also have on-chain randomness. Having a source of trusted and secure randomness is necessary for decentralized applications that depend on randomized processes. For example, lotteries, random NFT drops, games, and etc. We also have state proofs, Algorand state proofs, and I'm super excited to talk about this one. So quantum computers is coming, and with all new technology, we shouldn't fear it, we should embrace it. And the Algorand is definitely at the forefront of this. State proofs are a cryptographic proof of the account status. A snapshot of the accounts happen at a specific time, which is every 256 blocks. So in around 12 minutes, 12.8 minutes to be exact, the entire chain's history is quantum secure. We are 1/3 of the way to being a fully quantum secure blockchain, and we're leading in this innovation in the blockchain space. More research and development is underway on quantum secure VRF and transaction signature scheme. Those are the two last jigsaw pieces. So AVM versus EVM. Obviously, many of you probably know Ethereum. AVM basically stands for Algorand Virtual Machine. And this is where I wanted to talk a little bit more about instant finality. So instant finality is the time to finality that basically measures the time it takes for a transaction to become irreversible once it is confirmed and added to the blockchain. And with Algorand, it's just instant. So it takes its block second time and then it's instant. Whereas many other blockchains, it has their block second time, and then it could be a few minutes or a few seconds for it to be finalized on the network, which is quite a jump into the modern day blockchains like Algorand. So that's our CTO, John Woods. So it's built for the builders. It's all about developers, and developers for Algorand. So let's get into the best developer experience for blockchain. Soon, we will be going to our GitHub Codespace to code Python and Algorand together. I have a new link for that, but I will show that later and I'll make sure everyone has time to get on it. So start getting your GitHubs ready, make sure you're signed in. But while we're on the side, talk about Algokit, which is the tooling used to start coding smart contracts, your back end, your front end of your decentralized application. And down the line, we've just released Python in, I believe it was March. Down the line, we're going to have a plug and play library of smart contracts, which will be in 2024. And then we'll have improved debugging and integration of an additional common programming language in 2025. So Algokit changes the blockchain developers game. From the command line, compiler, top class libraries, easy to call smart contracts with client generator, instant access to testnet tokens, and of course, what does every developer Web 2 or Web 3 need? A solid debugger, or at least for me. So I'm really excited to see a specific Algorand virtual machine debugger. As you know, Python is used to code machine learning and artificial intelligence, and thanks to Algorand, now smart contracts. It's not just another variation. It opens up the gates to tens of millions of Python devs. Now, let's take a look at Python on Algorand, where we will do our live coding. So let me stop sharing my screen for a second, or let's see. Perfect. I hope you guys can actually still see my screen because I can stay on this. So we are going to move over to GitHub. So this will be the GitHub we are using. If you go to github.com/GANANIMTech, GANANIMTECK/Codespace_Algorand. I can try post that in the chat as well. Or if maybe, let me check.
Yeah, if you're not able to, you can send it to me on Telegram, but it should be next to the participants button at the bottom for you to share.
Perfect. I shared it in the chat there as well, and I'll make sure everyone has it if you're watching this on record. Perfect. Okay, I'll go back to screen sharing. Perfect. So this is the, I'll just give it another second. Perfect. So this is the URL, github.com/GANANIMTech/Codespace_Algorand. Now, once you are here, you can see the big green button. Maybe some of you are used to GitHub, maybe not, and that's totally okay. This is meant for everyone. So you come into your Codespace and you just click create Codespace on main. Now it takes a few minutes, so I'm going to click mine now to start getting ready. And what this is basically doing is it's setting up a virtual environment for you to code, because we're coding on the blockchain, which we got to remember. And you can set up your local environment. It actually takes less than 10 minutes, but I'll go through that after our live coding tutorial. But this is really neat about Codespace. And it's also a great place to just practice, but I believe Codespace is not free. Like after you have like a free allowance, and then you might need to get like GitHub Pro, I think, but I don't have that. So that's quite fun. It should all work for everyone. So we'll just give it a few more minutes to sink in. And don't mind about any of the pop-ups. If you get a pop-up for install Python extension, that's cool. You can install that one, but we'll do that later anyway. So right now we can see in our terminal, it is pipx install Algokit, which is the tooling used for Algorand, which is change the game. Just give it a few minutes. A good time for me to drink water, I think. So now what it's doing is it's starting the local net. So within the virtual environment, which is basically like its own private Algorand blockchain. And say, for example, for when I'm coding on my local environment, I'd have it on Docker, and it's like running my own mini private Algorand blockchain, which is kind of cool. What we will be performing today in the code. Oh, perfect, it's done. So while we are here, we just run one command because we're bringing you the latest dev tooling, which will be more publicly available soon. But for now, you get the latest stuff. So it's pretty cool. So we just run our bash script, which is sh algorand underscore setup.sh, which yeah, we'll just press enter and it'll start running that. I can put that in the chat as well.
And I think there's a question in the chat.
Okay, perfect. Let's have a look. So we could use this as an alternative to if we don't have Docker. Yes, Natalie. You can use Codespace and it'll set up your entire development to interact like locally except virtually, which is pretty cool. But I'll also show you it's not that hard to set up the local environment for Algorand, but we'll do that a little bit later on. I'm just going to post in the chat the command to make sure you have all the up-to-date tooling that we'll use a bit later. That's totally cool. This is a great place to just practice and get used to coding on Algorand. So I'll post the... So if you just run, I've sent it in the chat, if you just run that command, if you're on this part, when you enter your Codespace and let it all set up, then run this command and you're all perfect to go. And we can just start focus on coding. All right. So now if you see the left side of the screen, which is our main.py, which is our Python file, you'll see it's completely blank and that's all good. I just had my pop-up here. If you guys get your pop-up, that's perfectly good. I'm just going to quickly install it because I'll need it for the next section, but we don't need it currently for now, but if it just pops up, feel free to install that. So now let's start. So what we're going to be doing is we're going to import modules to interact with the Algorand blockchain. We're going to connect the client to localnet and instantiate a dispenser from our KMD, which is a key management daemon. I'll talk about it a bit later. Then we're going to create our creator Algorand account, fund the creator account, create an Algorand standard asset. So we're going to be creating a token today, which is really cool. Then we're going to create the receiver because we want to be able to move this asset, which is essentially what we'll be doing. We'll then transfer the asset from one account to another. So just make sure you've run that other command that I put in the chat, so you'll be able to do this. So let's get started straight away. So as I mentioned, we're going to import everything we need. So we're going to do from Algokit underscore utils dot beta dot Algorand underscore client import and open your parentheses. So it's pretty cool that we're getting the latest dev tooling. So in here, we're going to have Algorand client, comma, because we'll need the Algorand client to talk to the chain. Then we'll need the asset create params, because we'll be creating an asset, as well as asset opt-in, which I'll talk more about a little bit later as well. Asset transfer, as we need to transfer our asset. And finally, pay params. Great. So once you have all imported all these, we can start getting into the coding side of things. So firstly, we'll want to connect the client to the local net, which is the Codespace has already started our local net. So if we go Algorand equal to Algorand client, which we've just imported above, dot default local net with 2 parentheses. So this will allow us to talk to the chain. We also need a dispenser because when you're using a blockchain, you need to have, or at least for Algorand, need to have a minimum balance requirement. So let's get our dispenser, which is, since we're using the local net, there's dispensers already there for you. And we'll do dispenser is equal to algorand.account.dispenser. So it's quite readable. And remember your parentheses. So the key KMD is your key management daemon, and that's basically like our local net wallet. So we'll actually print this. Now you don't have to follow the prints, but if you want to follow along and actually see it working side by side, you can follow the prints we do inside of the terminal. So I just want to showcase to you guys the dispenser address, and so that we can run the code and actually get some satisfaction. So now if we go into our terminal, I'll just clear really quickly. And we do Python main.py because we're running a Python file. And we can see our dispenser address. Awesome. Now let's create our creator address. So if we just do creator is equal to Algorand.account, because it's an Algorand account, .random. So we're going to create a random one. And since every time we run this, it'll be a new random account, but that won't matter as it's all interacting in the same line. So don't worry about the .random. And let's actually have a look at that as well. So I'm just going to take my print statement down here. So we can see this is our dispenser address, which is not random because that's already there. And this is currently our creator address. So what we need to do now is fund our creator address. Oh, there we go. So we can do an Algorand dot send payment. Inside of this, so we're creating a transaction here. Inside of this, we'll have our pay params, which is a module that we imported from above. After you have your pay params, I want you to open up your parentheses. And inside here, we need to check out a few things. So we're obviously sending a transaction. So who is the sender? The sender for this current transaction will be the dispenser dot address. Make sure you don't forget your commas. It's a very simple mistake. Then we'll also have the receiver. Because we're sending a payment, we need someone to receive it, and we want the creator as we're funding the creator address. And then the amount. So we will send, I think this is 10 million microalgos. Microalgos is just use developer terms for sending algos. So I think this could be like 1 algo or 10 algo, but it's not a huge thing. But we use microalgos well in the developer space. But on the Algorand dev portal, they have everything you need to know. So here I'm going to now, when we run this, it will obviously send the transaction, but let's actually see it working. I'm going to print the algorand.account.get information. And we're going to get the information from the creator address. So we're going to actually have a look inside of the creator address. And what I'll do there, now you guys don't have to do this as it's just a print statement to showcase. I'm going to comment these ones out. So I'm just printing it here so you can see what it looks like before and then after the transaction. So if we go into our terminal again and we run Python main.py, perfect. So this is the account information. It might look a little bit weird, but it has a lot of good information. So as we can see, this was the address, the random creator address, and that's obviously the same here and here. This was the first one where we can see we have amount 0. We sent our transaction and we now have an amount. And this is all without doing a smart contract as well, which is a pretty cool thing. So let's continue on. I'm going to comment those out just so it's easier to see the terminal when I'm showcasing to you guys. So now let's create our asset. So if we create a new transaction, so we'll call it sent underscore transaction. We'll have this equal to algorand.send because we're sending a message or we're sending a transaction to the network. And we're going to do algorand.send asset underscore create. Open up your parentheses. And if you've already looked above, we did pay params there. This time we'll be doing asset create params like we imported. So you can start to see some very similarities. Now we need to fill in what's needed. So the sender is basically the creator of it. And we've created the creator address to be the creator of the token. So our sender will be equal to creator.address, comma, the total. So the total amount of tokens, if anyone has a favorite number or a lucky number, I'll just do 333. And don't forget your comma. Then we'll have the asset name. So to keep it more relevant, let's call it build her. Perfect. So that's our asset name. And we can have our unit name, which we can have as her. Awesome. So let me get that writing out of the way. So this is us creating a token. Now what I need to do is extract the asset ID. So because it's always very handy to know the asset ID, or when you go more deeper into things, application ID. But for now, our asset ID of the above transaction is equal to sent transaction. Then we'll open up our square brackets and we'll have our confirmation. And open up another pair of square brackets and get our asset dash index. So we're extracting the asset ID from the confirmation of the sent transaction, and we can also print that as well. Great, so let's run this as well. I'll just comment out the rest of those. Great. We'll do Python. So here, this is our asset ID. It's 4 digits, 1003. Now we have to create our receiver account, and we have already used that code. So why don't we just copy and paste and be as efficient as we can be? So I'm taking our creator, the way we created an account, which is just algorand.account.random, and I'm going to change the name of the account instead of creator to be receiver. Let's make sure I spell receiver correctly. Fantastic. And we can print out that as well. Probably best to, just to make sure everything's working, best practice. So we can just print out our receiver. And I'm just going to actually quickly add on our receiver. I'm just going to do underscore account just so we can differentiate it when we're doing our sender and receiver inside of our transactions. So receiver account. And then we just do underscore ACCT dot address. I'll really quickly run that as well. Great. And that's our receiver address. So now we want to send the asset. We want to send build her from the creator to the receiver account. So let's get that started. So we'll have asset underscore transfer, which is the name of the transaction. We're going to have it equal to algorand.send.asset underscore transfer. I'm sure some of you can take a guess of what's next. We're going to fill out our asset transfer params. Our sender is going to be the creator address, as all the tokens is with the creator address. Our receiver, which is going to be equal to our receiver account. This is why I wanted to make sure they were a little bit different. Don't forget the comma, and don't forget the dot address either. Then we need to say what asset we're transferring, because how would it know? So to do this, we set our asset ID equal to asset ID. So it knows what asset it needs to transfer. And the amount, well, there's 333 in total. So let's just do 111 to send it. So I'm going to run this code now. I'm just going to comment that out. So if we go into the terminal and we run this piece of code, there will be an error. And this wouldn't be a proper tutorial if there was not a deliberate error. So if we see in our command line, the error we get is receiver error must opt in asset 007, which is the asset ID. So with Algorand, you need to opt into assets, which is a really good anti-spam feature. So that gives the user choice on what type of assets they want. Now the receiver wants some of these build her tokens, so let's opt in to these. So first we need to fund our receiver account. And we've already wrote that piece of code, if you remember, for our creator, because we're getting some testnet tokens from the dispenser, some algos. So if I paste this down here, and all I need to change is the receiver, since the sender is still the dispenser, and we need to put in our receiver account. Perfect. So now we will have some tokens in the receiver account, so it will be able to do actions. So the action we want to do is opting in. So algorand.send.asset underscore opt underscore in. Open up your parentheses, include the asset opt-in params. Then open it up once more, as we've been doing repeatedly now, so I'm sure you're getting more used to it. And in here, to opt into an asset, all you need is the sender, which is equal to the address you want to opt in, and we want receiver to opt in. So it's receiver account dot address. If you're getting any errors, just check your typos, or if you're doing dot address in your commas. Then we also need to send the asset ID that we want, which is asset ID. Perfect. So that's how you opt into an asset. And now let's finally send that transaction. So we've already wrote it out. So let's take it down here. And make sure you delete it from above if you're doing the same way as I am. Great. And finally, let's print so we can actually see these changes. So if we print Algorand dot account dot get underscore information, and then the account you want the information from, put them inside the parentheses, which is receiver account dot address. So before we run this, we've basically imported modules to communicate with the blockchain. We connected our client to the local net and initialized our dispenser. We created a creator Algorand account, or an Algorand account in general, and we named it creator. We funded that account so it can do actions. We created the build her token. We created the receiver address. We noticed we had to do an opt-in for Algorand's anti-spam feature, opt-in into an asset to give choice for users to what assets they want instead of just getting a bunch of assets spammed. Then we funded the receiver account as well as getting the receiver account to opt in. And now finally we're sending that transaction. So let's hope it runs. So Python main.py in the terminal. Fantastic. Let me just make this bigger. So if we go down to the bottom here, we can see this is our receiver address. Our amount's gone down a little bit because we obviously used an action, sending a transaction. There's a minimum fee. And we can have a look at our assets. So we have amount 111, which the creator sent to us. The asset ID is 1009. So we have successfully sent a builder 111 builder tokens from one address to another address. Perfect. So that's the part of the live coding tutorial, but it does not end there. The fun does not stop. I want to showcase to you guys also Algokit. So what we done was all without a smart contract, which is pretty powerful to be able to do that all without a smart contract. But now I'm going to show you the Algokit tooling, which you can stay in the exact same code space. So if you go to your terminal and you do Algokit init, which means Algokit initialize, we're going to initialize a totally new project. And within this, you get asked a couple of questions. So which of these options best describes the project you want to build? Smart contracts, dApp front end, smart contracts, and dApp front end. And it's so cool because with Algokit, you can have the back end and the front end already communicating with each other and able to send transactions and able to communicate with a smart contract template that's already there. So you can just focus on going in, changing the code to suit your project and what you want to develop. But for now, I'm just going to showcase smart contracts. And we're going to do it in Python, as this is a Python Algorand tutorial. The name of the directory, let's just call it build her. We'll leave it as hello world. The template is a hello world. I'm going to do starter, but you can have a production, and this is same for the front end ones, where like once you add your own spice to it, you can start deploying to mainnet. But of course, it's always important to test locally and testnet. So we're going to do tester. We're going to do Python again. And finally, we're going to run Algokit project bootstrap, which basically is just like a one command that makes sure your environment has everything, which is just really handy. If you're having a bit of an issue, normally that solves it. So now you would get either a pop-up or it'll just take you straight to where you need to be. I believe you guys can still see my screen. It should be setting up a new code space. This takes just a little moment, as obviously we're setting up Algokit and in a virtual environment. So it's pretty cool. But locally, when you do this, oh, and also if you get the pop-up for Python, you can install that. That's all good. But I already installed my extension. But yeah, so you're doing this virtually, but locally you can do this as well. So you don't need to worry about GitHub Codespace deleting after 4 weeks, because I think you only get like one code space for a month. Okay, so now we are in the project we just initialized using Algokit, which is our build here. And now if we see our smart contracts, we can go to hello _world, which is what we named it. And we can enter our Python smart contract. This is the code. Today I'll just be deploying, as we've already done quite a bit of coding. But I want to showcase how easy it is to do that. So I also really quickly wanted to show the CLI, the command line of Algokit. Perfect. So here are a bunch of commands you have with Algokit, which makes it so much easier, from compiling the smart contracts, using the dispenser. Doctor is a great one if you're like, oh, I don't know why this isn't working, and it will tell you like, oh, you haven't installed something that you need. And then we've used init, and we also have local net. So if you are working on the local net, you can do it all from the terminal, and you can just focus on coding. Perfect. Now, what we're going to do is we're going to go to the left-hand side, go to run and debug. And we can see we have a bunch of a build, deploy, build and deploy together. So I think we'll build and deploy all together. So if you just press play, and we've just initialized this project. So it's going to build out, well, first it's going to start the local net. Oh, I must have double clicked it. I'll just cancel that. So now it is building out the project, and soon it will deploy. Perfect, it is now deploying. And it is successful. We've all, if you followed along, or if you do it later, we have just deployed a smart contract on our virtual local Algorand blockchain. And we have received hello world, which is pretty cool since print hello world is a pretty iconic coding line. And after you build and run, when you build it, you will notice an artifacts folder, which is basically compiling all this Python code into TEAL, which is transaction execution approval language, it's like the native language for TEAL to speak to the AVM, the Algorand virtual machine, but we don't need to mind about that because we can code in Python. There might be a question in the chat, so I'm going to quickly check that. It's deployed to local _net. In this virtual machine, we don't need to worry about local net since the Codespace itself already does that and sets it up. But this is a great segue. Since we've done our coding side, I want to show you guys how easy it is to actually set up your environment. So I'm going to take you to the right resources. So still on my screen, if we go to our Algorand developer portal, oh, there we go. So here is our Algorand developer portal, which the Algo devs have done a great job of. Lots of great docs, and there's even an AI helper on there. So if you had a question, you can type it into AI and it'll find the right resources for you. Or if you want to, if you're a bit more into communicating, I want to see more code, you can go to our Discord. I believe it's Algorand. It's like discord.gg/Algorand. So in here, if you're more into watching videos, we have a 10-minute tutorial. It's also part of this series where you can also build a dApp in 10 minutes, but you can there's videos to set up in Mac OS and in Windows. Here are some of the prerequisites. So Python 3.12 or higher. I do really recommend if you're following the 10-minute tutorial videos on YouTube, which are super great. Since like they may be like a older version, still 100%, but just make sure you check that it's the latest version for yourself when you're downloading on your own computer, because it's always good to be up to date with everything, even just in general. If you are more into just reading and how to install, say if you like using the command line and you don't want to go to other web pages, all of the command line commands are here, as well as you can click on these, say like Docker, and you can see that you can download it from the exact official website as well. So there's plenty of ways to do it. It takes 10 minutes. And if some of you guys are already developing for a long time, you might already have a lot of the prerequisites. So I really recommend that. I will put that in the chat really quickly. And also when we're on Telegram later, you can ask any questions too. Finally, I would like to finish the last part of my presentation. So let me just go back over here. I'm going to, only a few slides left. Let me just make it big screen so you guys get the full cinematic effect. Okay, fantastic. So we just did a live coding tutorial, and we also deployed a smart contract on Algorand, which is fantastic. Great job. So now it's your turn to get started. You can get support every step of the way building on Algorand. As I've showed you the developer portal, we also have AlgoDev's YouTube channel, which is where you'll see how to set up your environment, but also if you're one of those people who love to watch a 34-hour marathon and just become an expert in something, we have that as well in TypeScript. And I'm sure Python ones will be coming out very soon as well. But we also have small bite-sized ones that are like 10, 15 minutes long as well, or if you just want to learn more about blockchain. And basically the Algokit overview, as you've seen, building and deploying template contracts is as easy as filling in a form. So you can just focus on coding your next big project. I also want to say and inform you guys that we have boot camps, so which are completely free, by the way. So on the bootcamp side of things, the intermediate Python is starting May 20th. I have QR codes in the next slide for everyone to scan. But there's beginners can build a full stack Python or TypeScript based digital marketplace, which they just did. And you can learn blockchain fundamentals and deploy your first smart contract, which you guys are already ahead in. We also have the intermediate developers, so you can refine the marketplace that you would have built in the beginner series with advanced features like unique contracts and listing fees and just deepening your knowledge. So the dates for that, as you can see on the screen as well, the 20th to the 23rd of May and the 27th to the 30th intermediate for any Spanish speaking folks. July and August, again, we'll have beginner and intermediate Python. So don't worry if you don't think you're ready, or it's always good just to join anyway and get used to seeing how to interact with the blockchain. We also have just recently launched our first global hackathon of the year. Oh, before I do that, I just think I see a question. No problem at all, but don't leave just yet. I have something very exciting to show you guys. So on the left-hand side, we have our hackathon, which I'm going to speak about, but feel free to scan. And on the right-hand side, we have the bootcamps page, which will take you there officially. So put your interest in. It's very simple, just a quick form sign or like that. But basically, the Algorand Global Hackathon this year is called Change the Game. The key dates are the registration opened April 17th. It's still open. The official hacking window starts May 15th to June 12th. The finalists will be announced on June 19th. We'll have a Grandmaster demo day on June 27th. And this is a virtual global hackathon. You have a chance to pitch at the Cypher in Barcelona. The Cypher is basically the big event Algorand does mostly once a year. We also have phenomenal prizes. First place is 8,000 USDC, second place 5,000, third place 3,000, and there's 3 tiers for that, which the tracks for that are DeFi, consumer, and interoperability. 2 other bonus prizes. One is the best AI project that has AI integrated, and you get 2,000 for that. One that I'm really excited to tell you guys is the best female lead team. And I think the best place in female team, no matter where you come, is 2,000 USDC. So it's just worth it to give it a go, especially with these tools you've seen today. And there's so much content out there, and the algo devs are ready to help. So why join? I guess connect with top tier investors like DWF Labs, Optio Capital, and Borderless Capital. You can dive deep into Algorand's technology with support from partners like Para Wallet, Amazon Web Services, Folks Finance, and more. You can showcase your project to judges, VCs, and potential collaborators, gain hands-on experience and guidance from expert mentors, and access 24/7 Algorand Foundation's developer relations support to bring your vision to life. Just to reiterate, the tracks are DeFi, so decentralized finance, consumer, and interoperability. And all the placing teams receive a $300 USDC bursary for Decipher 2024, which is in Barcelona. And it's complimentary hotel accommodation for a team member and a exclusive chess set. So any big chess players out there like myself, it's a good thing to go for. And yeah, I guess if I can take any Q&A now, I'll also be in the Telegram, but that's about the end of the presentation. I'll keep the QR codes up for a bit more, but feel free to put any questions in the chat.
Thank you so much. That was really, really easy to follow and surprisingly intuitive. So, yeah, I'm sure everyone here appreciates it. And we're really grateful for your time. And yeah, let's give people a few more moments to see if they have any questions here. Like I had mentioned earlier and have dropped in the chat, a link to the Telegram group that you can join and ask any questions along the way. And I'll drop that again here.
And for the coding question, yes, I'm very happy to share that. So, and I also have one that has all the comments. So if you have like a question as well, it will be there too. So I'll put that in the Telegram. So that's some initiative to join the Telegram. So it's easier for us to all connect after this as well. So yeah, join the Telegram, and in there I'll be there for like, I guess another hour, an hour and a half, and I'll answer any questions. And if you have any questions that pop up along the way or even way after this, please feel free to connect with me on any platform. And I'll share
Awesome.
that code in the Telegram. Perfect. Thank you so much, Rex.
Yeah, no, thank you. Thanks, everyone. And a reminder that this is the highest valued workshop. So I really encourage everyone to continue. And if you have any questions, please do ask. So yeah, thank you so much, Sarah. And yeah, everyone take care. We'll be posting the video of this later. But yeah, another hour or so in the Telegram for any direct office hour questions. Thanks, everyone. Bye.